Welcome to this presentation on elasticity. Price elasticity of demand can be a confusing concept, so the purpose of this presentation is to help clarify elasticity and the concept of price elasticity of demand. We'll talk about what elasticity is, how it works, and the effects it has on revenue. The definition of elasticity is simply the deformation of an object under stress. If you think about a rubber band, as you pull the ends of the rubber band apart, you apply force. The band stretches. So how does this apply to economics? There are different forces in economics, such as price and income. These forces act on things such as supply and demand. So when we change the price of a can of peas, the demand for those cans of peas will change. The force being applied is the change in price. This is affecting the demand for those peas. Typically, when the price goes up, demand will go down. This is the law of demand. There are several different types of elasticities. First of all, there's price elasticity of demand. This refers to the change in demand resulting from a change in price. Demand is defined as the quantity of product consumers are willing to buy. It's sometimes referred to as demand quantity or quantity demanded. There's also the price elasticity of supply. Supply changes when there's a change in price, just like demand does. Typically, there's a positive correlation between price and supply. As the price goes up, supply goes up. This is the opposite of the law of demand. When the price goes up, demand goes down. One type of elasticity you may not be familiar with is income elasticity of demand. This refers to what happens to demand when consumer incomes change. As our incomes go up, our demand for certain products will go either up or down depending on the specific product. For each of these types of elasticities, force is applied in the form of price or income, and the deformation that takes place is in the form of supply or demand. So again, think about the analogy of the rubber band. As we apply force to the rubber band, we stretch it, we deform it. So we're going to talk about price elasticity of demand. Now, the law of demand dictates that when there's a change in price, there's a change in demand. Typically, there's an inverse relationship between the two. As the price goes up, demand goes down. This is something that we're already familiar with. Price elasticity of demand measures how responsive that change in demand is compared to the change in price. Think about our rubber band. The band might be considered the demand for our can of peas. The force we apply to the rubber band would be price. If the rubber band stretches a lot, in other words, demand changes substantially because of a change in price, we would see this as being elastic. But if we change the price and the rubber band doesn't stretch, we would consider this inelastic. So this brings us to relative elasticity and inelasticity. For relatively elastic items, a price change has a large effect on the quantity demanded. More specifically, the percentage change in demand is greater than the percentage change in price. For relatively inelastic items, a price change has a small effect on the quantity demanded. The percentage change in demand is smaller than the percentage change in price. There's a formula that measures elasticity. This applies to all elasticities: price elasticity of demand, price elasticity of supply, income elasticity of demand. We're going to cover price elasticity of supply and income elasticity of demand in a later presentation. Any variable can be inserted into the numerator and denominator. The numerator is the variable on top. In this case, it's percentage change in A. The denominator is the variable on the bottom. In this case, percentage change in B. For something to be elastic, the coefficient of elasticity needs to be greater than 1.0. This means that the numerator, the percentage change in A, is greater than the denominator, the percentage change in B. For something to be inelastic, the coefficient is less than 1.0. This is when the percentage change in A, the numerator, is less than the percentage change in B, the denominator. Unitary elasticity is when the coefficient is exactly 1.0. Now this occurs when the percentage change in A and B are exactly the same. So the numerator and denominator are equal. Applying this to price elasticity of demand, relative elasticity is when the coefficient EP is greater than 1.0. Notice in our equation for price elasticity of demand, the percentage change in demand is in the numerator, and the percentage change in price is in the denominator. A relatively elastic item would be one in which the coefficient is greater than 1.0. So therefore, the percentage change in demand is greater than the percentage change in price. So a 1% change in price will cause a greater than 1% change in quantity demanded. Now this percentage can be any percentage, 1% or 300%. What's important is that you're comparing the percentage change in demand with the percentage change in price. Also consider that you're comparing a percentage with a percentage. You can't compare a price change with the quantity change. For example, you can't insert a $5 change in price and a 12 can of peas change in quantity demanded. The numerator and denominator need to use the same units of measure. So in this case, we're comparing the percentage changes. So for relatively elastic items, we see that the demand is sensitive to changes in price because the percentage change in demand is greater than the percentage change in price. For example, a 5% increase in price might result in a 15% decrease in demand, or a 5% decrease in price might result in a 15% increase in demand. And now this is the rule for luxury items. Consider the fact that we don't need luxury items. We can do without them. So we're less likely to tolerate an increase in price, but we might welcome a decrease in price. Now, relative inelasticity refers to when the coefficient is less than 1.0. Now, this isn't necessarily a negative number. That would mean that the coefficient is less than 0. We're talking about a coefficient that is less than 1.0, but greater than 0. This means that the percentage change in demand in the numerator is smaller than the percentage change in price in the denominator. So what this means is that the demand is not sensitive to changes in price. Consider necessity items, toilet paper and gasoline. If the price of toilet paper goes up, we still buy it because we need it. The price of gasoline has increased in the past decade quite a bit, but we still need it to get to school or to work, so we still buy it even at the higher price. However, demand does change with the change in price for relatively inelastic items. When the price of gas goes up, we might drive less. We might consolidate all of our errands into one trip and use less gas. In the long run, we might end up purchasing a more fuel-efficient car. Have you noticed the proliferation of smart cars and hybrids on the freeways in the past 10 years? A Ford Explorer might get 16 miles to the gallon, a Hyundai Accent 32 miles to the gallon. So by downsizing your car, you can reduce your demand for gasoline by half. So despite the fact that gas is a necessity and we still buy gasoline when the price goes up, our demand still does go down a little bit. But the percentage change in demand is less than the percentage change in price. For example, if the price went up 15%, demand might go down 2%. Unitary elastic items are where the percentage change in demand is exactly equal to the percentage change in price, but in the opposite direction. This is rare. Most items are either relatively elastic or relatively inelastic, but there's a point at which items might become unitary elastic. Perfect elasticity refers to any increase in price resulting in a reduction in demand to 0. This is theoretical, and no good or service is really perfectly elastic, although commodities come close. For example, if Joe and Fred sell identical corn, there is no difference between their product. Therefore, demand is based solely on price. If Joe raises the price of his corn from $4 a bushel to $5 a bushel, all of Joe's customers would buy Fred's corn at $4 a bushel because of the fact that their products are identical. Joe would lose 100% of his demand. So the numerator, the percentage change in demand, would be 100%, regardless of the percentage change in price. Perfectly inelastic items, or perfect inelasticity, might be a little bit easier to understand. Remember that inelastic items are those in which the percentage change in demand is less than the percentage change in price. Consumers tolerate an increase in price because they're usually necessities. Now, to be perfectly inelastic means that there is absolutely no change in demand with a change in price. In other words, the numerator or percentage change in demand would be zero regardless of the change in price. Consider the drug insulin. Diabetics require it for survival. Without it, they would die. Therefore, diabetics would pay any price for this drug. So a 100% increase in price would result in a 0% decrease in demand. And this is when an item becomes perfectly inelastic. So what determines the price elasticity of a product? There are several determinants of price elasticity. Probably the most important determinants are the necessity of the product, which we already discussed a little bit. Necessities are usually relatively inelastic. We need them, so we tolerate price changes. If the price of toilet paper goes up, our demand doesn't go down that much. Luxuries are more elastic. We can do without them, so we won't tolerate a price increase. Therefore, the percentage change in demand is greater than the percentage change in price. There are psychological determinants as well. Sales are great examples. As consumers, we know that sales are temporary reductions in the price of a product, and the price is eventually going to go back up. So when an item's on sale, we buy that item because we know the price will go back up in the future. This increases the percentage change in demand for that item. So an item that's priced at $5 might decrease in price by 10% to $4.50, which will cause demand to go up by more than 10%, which means that the item becomes relatively elastic. How easily can we substitute one item for another also plays a role in the elasticity of a product. If there's many different substitutes for that item, elasticity will be higher because we can substitute a cheaper product for a product that has increased in price. Geographically broader market areas also contribute to the ease of substitution. Consider a small town in Nebraska with 700 people at one grocery store, and it's 25 miles to the next town. The geographical market area is very narrow. So Fred's Grocery can increase the price of his bread because there's no substitutes in the immediate area. In San Diego, there are 15 different places to buy bread within a 3-mile radius of my house. This represents a very broad geographical market area. If the price of bread at XYZ Grocery goes up, I can go to ABC Grocery and get cheaper bread. So this increases the price elasticity of that product. I already mentioned how a longer time increases elasticity. We might tolerate a price increase in the long run and adapt our behavior to reduce our demand. Gasoline's a good example. Gasoline is relatively inelastic. We need it to go to work, to go to school, to take our kids to soccer practice, to run our errands. So if the price of gas goes up, we still buy it. But if the price of gas stays high, we might adapt our behavior to reduce our demand. Perhaps we carpool with a teammate to soccer practice or consolidate our errands into one trip. Or we might buy a more fuel-efficient car. What this does is it reduces our demand for gasoline in the long run and makes it more elastic as time goes on. How much we spend on goods also affects the elasticity of the product. If we don't spend a lot of money on salt, for example, a pound of salt increases from 50 cents to $1, our demand is not likely to go down very much. But if we spend a lot of money on a good, it tends to be more elastic. A larger portion of our monthly paycheck might be spent on a washing machine. Therefore, we won't tolerate a price increase because of the amount of money we're spending on it in the first place. Here are some elasticities of various products. Notice the coefficient for meals at restaurants is 2.27. Also notice the negative sign. This is because of the inverse correlation between price and demand. As price goes up, demand goes down, and vice versa. That means these coefficients are negative. However, we're really only looking at the size of the change or the magnitude of the change. We're not really concerned with the direction of the change, so we can ignore the negative sign. Air travel over the Atlantic and in the United States are both relatively elastic with coefficients of greater than 1.0. Air travel over the Atlantic being 1.2. Air travel in the US being 1.98. Notice the elasticity of gasoline in the short run is 0.3, but it becomes more elastic in the long run, up to 0.6 to 0.8. Again, this is because of the passage of time and how we change our behavior in our consumption of gasoline. Despite the fact that it becomes more elastic in the long run, it's still considered relatively inelastic because even at 0.6 or 0.8, the coefficient is still less than 1.0. Again, luxury items such as eating out or air travel are typically more elastic, while necessities are typically less elastic. So what happens to revenue when the price changes? As the owner or manager of a store, we have to understand the elasticity of our individual products. We already probably know that when we increase the price of our can of peas or toilet paper, demand is going to go down. When we decrease the price, demand is going to go up. So as a manager armed with a pricing gun, what price do we set for our products? Keep in mind that businesses need to maximize their revenues and profits to stay in business. Choosing the right price means that we need to understand the price elasticity of each individual product. One product might see an increase in revenue with an increase in price, while another product might see a decrease in revenue with an increase in price. So the rule of thumb is that revenue follows the greater percent change. So for relatively elastic items, those luxuries, the percentage change in demand is greater than the percentage change in price, and revenue will follow the change in demand. So when we increase the price of our Rolex watches, the percentage decrease in demand is greater than the percentage increase in price. Therefore, revenue will follow the greater percent change, which is the decrease in demand, and revenue will go down. Remember that Rolex watches are considered luxuries. Consumers won't usually tolerate an increase in price for a luxury item because they can simply do without them. If we increase the price of generic bottled water, considering that generic bottled water is the cheapest water that we can buy other than tap water, and water is really considered a necessity, when the price goes up, demand is going to go down. However, the percentage increase in price is greater than the percentage decrease in demand because of the necessity of the item. Revenue follows the greater percentage change, and since the percentage increase in price is greater than the percentage decrease in demand, revenue goes up. So you can see that depending on the elasticity of the product, an increase in price can either increase or decrease revenue. Unitary elastic items are easy. An increase in price results in the same percentage decrease in demand. This means that there's no change in revenue. We talked about a price increase for both elastic and inelastic items. Now pause the presentation and think about what would happen if we decrease the price of these products. What would happen to demand and what would happen to revenue as a result of a price decrease? This graph represents the relationship between total revenue and a change in price and demand. On the bottom graph, the vertical axis is price per unit. The horizontal axis is the quantity demanded. If you look at the far left-hand side of the yellow line, the price is very high. The quantity demanded is low. In fact, it starts at 0. As the price comes down, the quantity demanded increases along the horizontal axis. This is the relatively elastic side of the graph, and the percentage change in demand is greater than the percentage change in price. If you look at the graph on the top, TR stands for total revenue. Total revenue is in the vertical axis, while the horizontal axis still represents the quantity demanded. You can see that the total revenue is 0 at the far left-hand side of the graph. That's because demand is 0 due to the fact that the price is very high. So when nobody's buying your product, you're not making any money. As the price comes down, you can see that total revenue increases while the product is relatively elastic. You can see on the bottom graph, it says elasticity is greater than 1. Total revenue increases until it reaches the top, the red dot at the top, and then it stops. This is the maximum total revenue and also where elasticity equals 1.0, where the product now becomes unitary elastic. At this point, the percentage change in price is exactly equal to the percentage change in demand. As the price continues to decrease and go down, the product becomes cheaper and cheaper, and it now becomes relatively inelastic. The percentage change in demand is less than the percentage change in price. If you look at the total revenue graph on the top, you can see that the total revenue curve slopes downward and total revenue decreases as the price continues to decrease and demand continues to increase. At this point, pause the presentation a few moments to look at the price and demand graph on the bottom and follow the demand curve as the price increases and decreases and see what happens to the total revenue in the graph at the top. I hope you enjoyed this presentation and that it was enlightening for you. I know we covered a lot of material, but the great thing about these presentations is you can pause and rewind. Feel free to go back, review the material in order to get a better understanding of these extremely important concepts. Remember how important price elasticity of demand is. A retail manager or business owner should know the price elasticity of demand of their individual products so they know how to properly price them. An increase or decrease in price can result in an increase or decrease in revenue. The trick is to price the product so as to maximize revenue.